Welcome. In this video, we are going to discuss about the inference concerning two proportions. In the previous video, we considered a population. Okay, this population were divided into two categories. That is, having an attribute x and does not having the attribute x. Okay, here in this video, we will consider two different populations, and both the populations are divided into two things. That is having the attribute x and does not having the attribute x. Okay, now we will calculate the proportion. Suppose this one we take it as like x. Suppose if we are talking about the number of people having the attribute, that one we take it as x1, and here we will take it as x2, and the sample size here would be n1, and it is denoted as n2 for the second population. Okay, and the remaining calculations are almost the same. Okay, so only the statistic would be different, and the remaining everything are going to be the same. Okay, and here the test would be if there is a significant difference between these two things. Okay, if suppose the test is the test is to test the null hypothesis is to test if they are differing by some certain quantity delta, then what would be the test statistics? It is x1 upon n1 minus x2 upon n2 minus the delta, and it is the same, right? There it was only this term. Here you have the other term as well. Okay, and the critical region are similar to that of the previous ones. Okay, suppose we are going to calculate the equality of two proportions, that is our delta value is 0. Okay, when our delta value is 0, so our z was x1 upon n1 minus x2 upon n2 whole thing divided by under root x1 upon n1 multiplied with 1 minus x1 upon n1 divided by n1. It was the case, right? Isn't it? Yeah. So plus x2 upon n2 multiplied with 1 minus x2 upon n2 whole thing divided by n2. This was the thing. Now let us just take the denominator thing, only the things in the under root. Okay, only this one we are doing the calculation. So it is x1 upon n1 1 minus x1 upon n1 product with n2 plus x2 upon n2 multiplied with 1 minus x2 upon n2 product with n1 whole thing divided by n1 n2. So if we just take the LCM, this is what we have. Okay, this is x1 n2 upon n1 minus x1 square n2 upon n1 square, isn't it? Plus x2 n1 n2 minus x2 square, it is x2 square n1 upon n2 square, and the whole thing divided by n1 n2, right? Okay, so here we will try and do some manipulation. Okay, so the man, okay, and remember and see, here it is given that x1 upon n1 minus x2 upon n2, the numerator is the same, whereas in the denominator we have some other quantity. Okay, how like if we simplify this one, if we proceed further, we just calculate like, so everywhere this n1 n2 would be there, right? So it is n1 n2 here also, and again n1 n2 n1 n2 and n1 n2 would be there with everywhere. So this n2 n2 gets cancelled, n2 n2 gets cancelled, and here n1 n1 gets cancelled, and n1 n1 gets cancelled, and finally what we have is x1 upon n1 square minus x1 square upon n1 cube plus x2 upon n2 square minus x2 square upon n2 cube, right? And here, so can we make something in common? That is kind of not okay. So if we take x1 upon n1 square as a common quantity, so we will have 1 minus x1 upon n1. Similarly, x2 upon n2 square as a common quantity, it would be x1 minus x1 upon, sorry, x2 upon n2. Okay, we further have to make some simplification and finally arrive at this thing. Okay, again we'll have to take some LCM and do some calculation, and finally we would have something of this form. And here this p cap is x1 plus x2 upon n1 plus n2. Or if you don't like, if you feel this is kind of some new thing to be remembered, you can also proceed with this itself without changing anything. That is also fine. Okay, and here, okay, here the question is, in a random sample of 400 voters of city A, 230 were in favor of candidate K. And in a sample of 500 voters of city B, 200 were in favor of candidate K. So here the attribute is in favor of candidate K. Now we'll have to test whether the proportion of voters favoring candidate K are the same in both the cities, and we are asked to use this 0.05 level of significance. So it is understood that N1 is 400 and N2 is 500. Okay, X1 is 230 and X2 is 200. We calculate this P hat, that is X1 plus X2 upon N1 plus N2. We just calculate it. Okay, here the null hypothesis is whether uh, the favorism is the same. So that is P1 minus P2 equals 0 against the against the alternate hypothesis that P1 minus P2 is not equal to 0. We just substitute these values in the test statistic and we get it is 5.224. Absolutely absolute of Z is greater than Z alpha upon 2. Therefore, we reject the null hypothesis. Therefore, the favorism is not same in both the cities. Moving further, here in this problem, it is given that in a large city A, 20% of the random sample of 900 school boys had a slight physical defect. Okay. In another large city B, 18.5% of the random sample of 1600 school boys had the same defect. So here the attribute is having some physical defect. Okay, now is the difference between proportions significant at this level of significance? We have n1, and to find out x1, it is 20 percentage of 900. We calculate it. N2 is 1600 and x2 is 18.5 percentage of 1600. We again calculate it, and p hat is x1 plus x2 upon n1 plus n2. That's completely fine. And we just substitute all these values in the test statistic and we see that absolute of z is smaller than z alpha upon 2. Therefore, we'll have to accept h naught. Okay. Suppose the same problem, if you want to do it using without calculating this x1 and x2, this z can be written as x1 upon n1 minus x2 upon n2 whole thing divided by under root x1 upon n1 multiplied with 1 minus x1 upon n1 divided by n1 plus x2 upon n2 multiplied with 1 minus x2 upon n2 whole thing divided by n2, right? So we know n1 and n2 directly. So n1 is 900 and n2 is 1600. Okay, so like x1 is 20 percentage of n1, right? So that is 20 percentage multiplied with n1 upon n1 if you are in a need to calculate this thing. So finally you remain with 20 percentage, that is zero point 0.2 itself. Okay, in a similar way you would have your x2 upon n2 would be what? It is 18.5. So therefore directly you can substitute it as 0.2 minus 0.18 divided by under root zero point 0.2 multiplied with zero point 0.8 upon 900 plus 0.185 multiplied with 0.815 divided by 1600, and you, if you calculate it again, you will get the same value approximately. Okay, this can also be done. Okay, not necessary that you will have to calculate the values of an x1 and x2 separately and do with this p hat and all. You can go with the first formula as well, right? So the things are up to you. Now the next idea is to find the confidence interval, and I hope by this time you might have got the idea to calculate the confidence interval from the test statistic. So, if this is the test statistic, absolute of z less than z alpha upon 2. So, basically, absolute of z less than z alpha 2 is the region of acceptance. Okay, and some expression for this z is there. From this, for what we are trying to find out the confidence interval, that we can deduce. Okay, through that only, here we have the deduced form for the confidence interval for p1 minus p2. And here in this problem, if you see, it is given that 16 out of 200 tractors produced by one assembly line required extensive adjustment before they could be shipped, while the same was true for 14 of 400 tractors produced by another assembly line. Now we need to find out the confidence interval with 95% confidence for the difference of the true proportions. So n1 is 200 and x1 is 16, n2 is 400 and x2 is 14. And from the standard normal table, we calculate z alpha upon 2 is 1.96. Right? So we just substitute all these things into it. So like substitution is not a big deal, right? So 16 upon 200 minus 14 upon 400 minus r plus 1.96 times of under root, it is 0.08 multiplied with 0.92 upon 200 plus 0.035 multiplied with 0.965 upon 400. So this gives you approximately 0.0033 comma 0.0867. This is the required confidence interval. That's it. Thank you.